Hey everybody, this video is meant to help you out with our first assignment here, dividing polynomials with remainders. The learning goal is to rewrite rational expressions in the form q of x plus r of x divided by b of x. So we're moving on from polynomials to start talking about rational functions. Rational functions are just two polynomials that are being divided. An important strategy is dividing. Dividing them helps us rewrite it into a different form that can be useful for us. Just like polynomials, we had multiple forms. Well, rational functions have multiple forms as well. So what we're going to do is we're going to look at a few examples here, and then you'll have some problems to do on your own. We're going to rewrite this rational expression, which is kind of in this form, a of x over b of x. In this case, a of x is what's in the numerator here, and b of x is what's in the denominator. We're going to write it into this form, q of x plus r of x divided by b of x. Q of x will be our quotient, r of x will be our remainder, and b of x is, well, just this denominator. We have two strategies that we can use to divide. First strategy I'm going to go through is using diagrams called area models. So using area model diagrams. We'll take a look at this to start us off. All right, so to use an area model diagram, well, we have to set up a box to divide this whole thing. We have x cubed plus 4x plus 5x plus 2 divided by x plus 1. So I'm going to set up a rectangle here. And what we have here is, well, we know that we're going to be multiplying x plus 1 by some other factor to get x cubed plus 4x plus 5x plus 2. So when I do this, I'm going to create a diagram that looks like this. All right, so I have a 3 by 2 diagram here. Right here, I'm going to have x plus 1. The other factor that I multiply by will be up here. Out of each diagonal, I get x cubed plus 4x squared plus 5x plus 2. So now we just have to basically piece in the rest of our diagram. I know that x cubed is the only thing that can fit here. So I got an x cubed hanging out right there. And now we just start asking ourselves the question, what times x is equal to x cubed? Should be pretty straightforward, that's x squared. Now we go down here. We have x squared times 1. X squared times 1 is x squared. And now we do a little reverse thinking. Well, this section plus this section should equal what comes out of the diagonal, 4x squared. So that makes this need to be 3x squared. Because 3x squared plus x squared is 4x squared. And then we repeat this process. What times x is 3x squared? Well, 3x works because 3x times x is 3x squared. Then we multiply again, 3x times 1 gives us 3x. And repeat the process again. Now we have what plus 3x is 5x, 2x. 2x plus 3x is 5x. We check here. What times x is 2x? Well, 2 times x is 2x. Now we multiply 2 times 1 gives us 2. And hey, that is exactly what should have come out of this diagonal. We're good here. We got 2. In this case, there is no remainder. We have exactly what we needed here. We have a plus 2, plus 2. This all matches. We're good. So we have now rewritten this as x squared plus 3x plus 2. So that's our first strategy for rewriting this using area model diagrams. The other strategy we learned back in Algebra 1 is what we call polynomial long division. So I'm going to do that example over here. I'm not going to be specific about which one you get to use. You get to choose whichever diagram you prefer, using area model diagrams or polynomial long division. Long division looks exactly like what elementary school long division looked like, except now we have variables. So we can set up our division symbol here. Inside, we'll have our numerator, which was x cubed plus 4x squared plus 5x plus 2. So in here we have x cubed plus 4x squared plus 5x plus 2. We're dividing that by the denominator, which we knew was x plus 1. So we have x plus 1 here. And this algorithm works pretty much the same way as the diagram, just a little bit of reverse thinking here. Now we have to ask ourselves, well, x plus 1 goes into this how many times? Well, to start, we'll think x goes into x cubed how many times? Well, it goes in x squared times. I'll write it above its like term. So x squared goes above 4x squared. Wouldn't write it over here. And then I just multiply x squared times x, goes in evenly. It says x cubed here. It's an ugly 3. All right, and now we also multiply x squared by 1. X squared times 1 gives us x squared. And just like with long division, we now subtract. So I'm going to make this negative, and since this was positive, I'm going to make this negative as well. Subtract both of those. 4x cubed minus x cubed gives us 0, and 4x squared minus x squared gives us 3x squared. We'll drop down this 5x and repeat the algorithm. X goes into 3x squared how many times? Well, it goes in positive 3x times, because 3x times x gives us 3x squared. 3x times 1 gives us 3x. And again, we subtract both of them. If this was negative already, it would change to positive. Because it's positive, they both just become negative. 5x minus 3x is 2x. Drop down the 2 and repeat one last time. X goes into 2x how many times? Well, 2 times. 2 times x is 2x. And now we also multiply 2 times 1. That gives us 2. Subtract one last time. 2x minus 2x is 0. 2 minus 2 is 0. And we have a remainder of 0. And we can see we got the same exact thing, x squared plus 3x plus 2. All right, in our next example, we're going to look through this division. This one, spoiler alert, is going to result in a remainder. I just wanted to highlight the difference of this case here where there was no remainder, in this case where we will have a remainder. I'm going to set this one up using a diagram. I'm not going to do the long division. You can do that for practice on your own. So first method is our area model diagram. Setting up my diagram, make the rectangle, and I'm going to divide this into these sections here. I'm dividing x cubed plus 4x squared plus 5x plus 2 by x plus 3. So again, out of the diagonals, I'll have x cubed 4x squared five x and 2. But this time I'm dividing it by x plus 3. All right, so out of this diagonal right here, there's only one box. This has to be x cubed. So now I'll go through and piece it all together. What times x is x cubed? X squared. X squared times 3 gives us 3x squared. And now, same idea. What plus 3x squared gives us 4x squared? Well, that's just going to be x squared. X squared plus 3x squared is 4x squared. Now repeat the process. What times x is x squared? X. X times 3 is 3x. We need to get 5x out of this diagonal. What plus 3x is 5x? Well, 2x. And then here we have what times x is 2x? Well, 2. And then if we multiply 2 times 3, we get 6. Problem here is we wanted 2. Wanted 2 here. We overshot it by 6 or by 4 because we got 6. So that means we're going to have a remainder here. We wanted to get 2. We wanted to get this 2 right here. Well, we're overshooting by 4. Therefore, our remainder is equal to negative 4. I could calculate that by going 2 minus 6 is negative 4. If you wanted to do that, you can go 2 minus 6 gives us negative 4. So we have a remainder of negative 4. That is our function right here. We can now rewrite this as, well, our quotient that we got, x squared plus x plus 2. This whole thing right here is q of x. So x squared plus x plus 2 plus the remainder, which is negative 4. This is our r of x. So negative 4 divided by b of x. This right here is b of x. It was our denominator, what we divided by initially. And we'll have x plus 3 right here. And we have now rewritten this successfully in this form. If you'd like, you can practice this over here with long division and see that you should get this same exact thing. You should end up with a remainder of negative 4. All right, hopefully this helps. Good luck. Have fun.